The last stage, which is more for the end users, for the utilities, optimization and retrofitting on large scales. So I have a couple of examples for that. Normally, for the end user, it's important that they are not overspending energy. Of course, they want as much as efficient with energy use, and they also want to, of course, reduce as much as possible OPEX and CAPEX. And on top of that, they also want that their process performance is always optimal, and there is no problem at that end. So I think again they can benefit from all these different options using CFD. The first example is of a homogenization tank, where the client was really looking at the sludge mixing and was trying to avoid struvite accumulation in the tank. Struvite happens to be like very fine particles, which can accumulate and then probably will give you headaches when you are going for the sewage treatment later on. So they had a tank, but was causing problems with the accumulation of struvite. So one solution was to just have better mixing by installing extra propellers. So initially the plan was that they had 2 propellers on the side so that they can keep this whole tank in motion, so the liquid is completely revolving. But then we figured out that this is not enough, and you need a central mixer which can somehow provide you this vertical flow, so there's enough suspension of the particles. We tested several designs, for example, 6 designs in 6 weeks. And then we found out, if you look at these 2 figures, on the right side, you have actually 3 impellers. So 2 side impellers, 1 in the middle, in this case as well. The only difference from right to the left figure is the angle of the outer impellers. So the moment you make or turn the impellers in such a way that they start synergizing together. So the central impeller and the flow caused by the outer impellers is synergizing with each other. So they are not like counter-flowing against each other. So in the right example, there was a counter effect, and the right and the left, they are more in synergy with each other. You can see it actually in the next slide. Here I will just run the animation for 3 different cases. So this was a case when you just had the outer impellers. In this case, we already had the central impeller, but the angles were not optimal. And in third case, in scenario 2, you have the angles very optimal. So you will see the particles. So these are all particles which are actually fluidizing. In this case, they don't leave the central part. They are all accumulated here. So this is the current situation. By implementing some side impellers, you were able to move them, but they were still kind of caught up in this region where you had this flow against each other. But in this case, once everything is in synergy, you can see that the particles are completely in motion and are very good suspended. So this was a very interesting project where client was already going to implement. So in this case, we decided the impeller type, positioning, and of course also the specifications of the impellers. Another example is I have to go back. Yeah, so this is an example of a secondary settler, and the client was actually looking at increasing the capacity of the settlers by adding some extra retrofitting inside the settler, so that they can still have very good settling without compromising the effluent quality. So without having much more TSS in the effluent. First thing which we found out in this simulation was that it's very important that we do a 3D simulation of the settlers, which is conventionally not the case, because conventionally the CFD modeling of the settlers is mostly in 2D, which gives you some indication. But if you are going to test some features or some design features in the settler which are inherently 3D, 2D simulations cannot take that into account. So this is important, that if you're going to check, for example, certain baffles, certain walls, certain withdrawal systems, you have to be sure that your system is adequately designed inside the CFD to take into account all these details. So in this case, we tested 8 different designs, and it took us around 10 weeks. And we were able to actually also validate this, because this was a special type of sludge. So which was where PAC dosing was happening. So Sludge was like very good settleable. So we tried to validate this with our model, and we found that it was the CFD simulations or results were very much in line with the measurements. And then we tested different design scenarios, and we found out that scenario 1 was better than the scenario 5. So this was a very good finding, because scenario 5 apparently was the most expensive option for the clients. They were actually, because of the CFD, were able to choose. They were going to invest anyway, but then across different options, there was one option which was the most expensive, which was, in their opinion, going to be the solution. But eventually, CFD simulation showed that this was not really the right approach. Rather, a cheaper was a much better performing option. So definitely, capex was saved in this situation.